Good afternoon, everyone. This is Miss Wynn, and we're going to be working on sets, set operations, and number systems. All right, so let's get started on working some of these problems I have for us. Get the screen pulled up. Here we go. All right, so we have in front of us a Venn diagram. I drew out our Venn diagram right here. U is universal. So we have the letters in the alphabet from A all the way to H in the universe. For set A, we have the letters B, C, D, G, and H. And for set B, we have D, F, and H. And then set C, we have D, G, and H. So over here in the Venn diagram, this circle here is for set A. Then we have set B, and down here is set C. And anything outside of those circles are considered the universe. So let's fill in for set A. So we know we have the letter B, C, D, G, and H. I'll explain why those other circles are connecting with those. For B, we have F, and then we also have D and H. For C, it's D, G, and H. So the reason why D and H are inside all three circles is because D and H are in all three sets. The letter G is only in set A and set C. So let's work some of these problems. So we'll keep up our Venn diagram. I'll go through a couple and then we'll move on to the next problem. So this one, B union C. So what union means is the set of all elements that are in B and C. So pretty much all the letters that are in B and C. So let's look up here. We have D, F, and H, and D, G, and H. So our set for B union C would be D, F, G, and H. Now we'll go to B. So we have A intersect B. What intersection means is the set of elements common to both A and B. So the letters that are in A and also in B. Now with B, we only have 3 letters. So we look up here in our set of A. There's a D. We don't have B and C in set B. So we have a D. There's no F in A. So, and no G in B. So our other letter is H. So we have D and H are in both sets A and set B. We'll do one more just to make sure you guys are getting the hang of it. So B intersect C. So the letters that are in both B and in C. So we look up here to B. We have D is in both sets. Then it goes F, which is not in set C, and G is not in set B. But then they both have H. So our answer is D and H. Okay. So here's some more. We got, let's do this one right here. Let's do E. So when there's a line above the letter, that's a set of letters that in the universe, which is the U up at the top, that are not letters of A. So we'll go back up here and we'll look and see. So what the universe that is not in set A. So we'll look at the universal letters up here, which is A, B, C, D, E, F, G, and H. And then we'll look at A. There's no A in set A, so that's going to be one of our letters. We have B, we have C, we have D. There's U, or there's E in the universe, but there's no E in set A, so E will be our next letter. Then there's F, we don't have F in A. There's G, and there's H. So our 3 letters that's going to be for that problem is A, E, and F. We'll try to do a different problem. So here we go. Here's this another type of Venn diagram. This has shapes. Now for our sets, it's given us C, H, and T is for the shape. So circle, hexagon, and triangle. S and L is for the size of the shapes, small and large. And then we got the color red and blue. So now this one is, so, excuse me, L intersects H. So if you remember from before, what that means is it's both. So L is for large, so it's large, and then the H is for hexagons. So large hexagons. Let's go to the next one. C union H. So that's including both. So we got circles for the C and the hexagons for the H. Here we go for this one. Now we got T intersect with this line over the R. So whatever this letter is, which is for R stands for red, this means not. So we're going to just, whatever shape this T stands for, that's not red. So the T is for triangles. So triangles that are not red is what that set stands for. Now our last one is C, S, and R. So C is for circles, S is for small, and R is for red. So small red circles. Now we're going to get into some number systems. They want us to write the Indo-Arabic equivalent in each of the following number systems. So our first one we're going to start with is Egyptian systems. Now this is the problem they gave us, some little symbols, and over here I wrote out the key. So this right here is the pointing finger is what they're calling it, which is equal to, they're doing the power of 10. So 10 to the 4th power, which is equal to 10,000. This little symbol here, the upside down U, is considered a yoke, and it's 10 to the 1 power, which is 10. And then this little line is called a staff, so 10 to the 0 power, which equals 1. So in our problem, we have 3 pointing fingers, which will be 3 times 10 to the 4th. The upside down U's, we have 5 of those, so it'd be 5 times 10 to the 1. And then we have 4 staffs, which is 4 times 10 to the 0. So we know that 10 to the 4th is 10,000. So 3 times 10,000 will give us 30,000. 5 times 10 gives us 50. And 4 times 1 gives us 4. So the answer to this one is 30,054. These are kind of fun. I mean, they look a little scary at first, but once you get the hang of it, and as long as you have the key, you can solve almost anything. This one's a little difficult with the Roman system. Now, you know how if the number, like right here, we have over here in our key, M is equal to 1,000, C is 100, X is 10, V is a 5, and then the I or the 1, it looks like a 1, but it's actually an I, equals 1. So I have it broke down over here. So this M is 1,000. Now we have this C in front of another M, but since C is smaller than this M, that means we're going to take whatever C equals away from the M. So C is 100. So we do 100 less than 1,000. We got 3 X's, which is equal to 30, and a V and 2 1s is 7. So written out in our kind of numbers, we got 1,900 because there's 1,000 and that's 900. Plus 30 plus 7 gives us 1937. Here's an easy one for you guys. It gives us 2 symbols. We've got the Babylonian system. This little shape, like an arrow kind of pointing, is equal to a 10, and then this triangle upside down is equal to a 1. So we have 4 of those pointed arrow things, which each one equals 10, and then the upside down triangle is 1. So we got 40 plus 1, which is 41. Let's do one more. This one looks a little hard, but once you understand the system and the keys that they offer you, then you'll get it. It's the Mayan system. So we have this straight line, which is equal to 5. We have a line with a dot above it, which is equal to 6. 3 dots, which is 3. And then we have 3 lines with 2 dots on top, which is equal to 17. Now, the way they work their problems is a little complicated, but this is how we do it. So they do their addition vertically. So, and they work it out this way. We have this 5, so we're bringing it over. 5 times 18 times 20 to the 2nd power gives us 36,000. Then we have 6 times 18 to the 20, which gives us 2,160. Then we have 3 times 20, which is equal to 60. And then 17 times 1 is 17. So when you add all that up together, it's 38,237. All right, now here comes, this stuff right here looks kind of scary, and I was confused on how to work these until the little light went off in my head. So let's see if we can do this one. I want us to do a multiplication lattice square. Now, 28 by 32. So we make us a box, and we cut each box into half. We write 2 above this row and 8 over here for 28, and then 32 down this way. Now, 2 times 3 gives us 6. So we'll put a 0 up here and a 6 down here. 8 times 3 is 24, so we'll put the 2 and then the 4. Then we come down here. 2 times 2 is 4, so we put a 0 here because there's no number, and a 4. And then 8 times 2 is 16, so a 1 and a 6. Now, once you fill that in, you're like, now what? How is this helping me solve this multiplication problem? Here's the fun part. You draw out these little lines that you cut your boxes in half with, and then you add diagonally, right? Oh my goodness. So 6 is right here. You just bring it down because there's nothing to add to it. Now here we have 4, 1, and 4. So 4 plus 1 is 5, plus 4 is 9. Then we come up here to this diagonal. We got 2, 6, and 0. So 2 plus 6 is 8, plus 0 is 8. And there's 0, which we don't add it to nothing, so we just leave it blank. That gives us the answer of 896. So 28 times 32 is 896. I know, right? Come with it. So much fun. We'll do one more of these and then we'll move on to the next problem. This one, we're multiplying 3-digit numbers. I know it's a little tricky, but this little lattice multiplication makes it so much easier. You don't have to worry about how you're carrying your numbers over and making sure you're doing it right. So we make our boxes again. We have to have 3 rows because we have 3 numbers. So we put 273 up top and 628 along the side. It doesn't matter which number you put on top and which one you put on the side, but I just did it the way they had us work out the problem. So here we go again. 2 times 6 gives us 12. So here's our 1 and our 2 for 12. We have 7 times 6 is 42. Here's the 4 and the 2. 3 times 6 is 18. Here's our 1 and our 8. We have 2 times 2. Don't forget to put your 0 up here because we only have a 1-digit number, so we put the 4 here. 7 times 2 is 14, so there's the 1 and the 4. 3 times 2 is 6. Don't forget to put your 0. There's your 6. 2 times 8 is 16. The 1 and the 6 for 16. 8 and 7 is 56. There's our 5 and our 6. And then 3 times 8 is 24. So there's our 2 and our 4. Here we come to our addition part of this. So we bring down our 4 because there's nothing to add it to. Move up to our next diagonal. We have 6, 2, and 6. So 6 plus 2 is 8, plus 6 is 14. We bring our 4 down, and we mark our little 1 right there so we don't forget to add it to our next diagonal. 8 plus 0 is 8, plus 4 is 12, plus 5 is 17, plus 6 is 23, plus that little 1 we carried over is 24. So we put our 4, and we carry our 2. So we have 1 plus 2 is 3, plus 1 is 4, plus 4 is 8, plus 1 is 9, plus 2 is 11. There's our 1, and we carry our other 1. 4 plus 2 is 6, plus 1 is 7, and then we carry our 1 over because there's nothing to add it to. So 273 times 628 gives us 171,444. I hope you're getting the hang of this. We're running a little low on time, so we'll go to our rounding to the leftmost digit to estimate the following expressions, and then we're going to work it out exactly. So here's our problem they give us. 883 plus 465 divided by 134. Now it wants us to round to the leftmost digit to estimate. So 883, we're going to round it up to 900. 465 will get rounded up because of the 6, so it would be 500. And then 134 is actually going to get rounded down because of the 3 is below 5. So it'll be 100. So 900 plus 500 gives us 1,400 divided by 100 equals 14. So that's our estimation. Now they want us to go over here and calculate it exactly. So we have 883 plus 465 divided by 134. 883 plus 465 gives us 1,348 divided by 134 is the exact number of 10.06. Now, if you can see, there's a little difference between the estimated number and the exact number, but relatively close. There's only 4, a total of 4 that's missing because the estimation is up a little high. So if you remember, we had to round those 2 numbers up. So that gives us 14, but the exact number is 10. So they're pretty close in all actuality. Let's do another one. Okay, here we go. This one we have to multiply and add and divide. So we have 5 times 254 plus 523 divided by 35 plus 7. Let's do our estimation first because those are a little bit easier for me. So we got 5 times 254 is going to be rounded up to 300, and the 523 is going to be rounded down to 500. Now 35 plus 7 is equal to 42, so we're going to round that number down to 40. I should have worked that step out, and I'm sorry. I hope that doesn't confuse you guys. So 5 times 300 gives us 1,500 plus 500 divided by 40. So 1,500 plus 500 gives us 2,000 divided by 40, which is equal to 50. It's a nice, pretty round number, isn't it? Now let's work it out to get the exact number. So 5 times 254 plus 523 divided by 35 plus 7 is our original problem. So 5 times 254 is 1,270 plus 523 divided by 42. So 1,270 plus 523 gives us 1,793 divided by 42, which gives us the exact number of 42.7. Now there's a little bit of a bigger difference between our exact number and our estimation on this one compared to the first one, but not by too much, just 7.3. We'll work one more to make sure you guys are actually getting the hang of this. Now we're just multiplying and dividing on this one, so this should be pretty easy. So our original problem is 620 times 430 divided by 293. So to do our estimation first, 620 is going to get lowered down to 600. 430 is going to get rounded down to 400. And 293, of course, will be rounded up to 300. So we'll do 600 times 400 gives us 240,000 divided by 300 gives us a total of 800. Now to work the exact problem, we have 620 times 430 divided by 293. 620 times 430 gives us the number of 266,600 divided by 293 gives us the exact number of 909.9. So here's our estimation. Our estimated number is 800 and the exact number is 909.9. When you're working with the higher numbers, there's bound to be a bigger gap in the estimated and the exact numbers. So don't worry, but you can always double check your work. All right, this stuff right here we're fixing to do. It gave me a little trouble at first, but then we worked it out and I'm trying to make it harder than what it is. Let's see if I can help you guys simplify working the powers of 5s and stuff, or the 5th power. And I'm sorry, base of 5, not 5th power. Excuse me, sorry, I don't want to confuse you guys. Okay, so here's our first problem. We have 432 to the base power of 5 plus 133 to the base power of 5. So to work these, we're going to want to do this nifty little base 5 little number line kind of thing. Not number line, but little diagram here. So we have 5 to the 0 power, which is equal to 1. 5 to the first power is 5. 5 to the second power is 25, and 5 to the third power is 125. Now, I'll break it down for you. So our first number is 432. You might want to try to figure out, well, how is this going to plug into this little diagram I just did? Well, the 2 comes over here to this area. So we put 2 dots because there's 2 ones. There's 3 over here in the 5, so we'll put 3 dots. And right here is 4, so we'll put 1, 2, 3, 4. Those are just the places. So there's 4 in the 25 place, 3 in the 5 place, and 2 in the 1 place. So then we'll do 133. Now, we put 1 here, we put 3 over here, and 3 here. Now we're going to add them up. So when you get 5 dots in one area, then you're going to move it over. So like right here we have in the 1's place, there's 5. So we're going to circle that group of dots. I'm going to add us a dot over here. Oh, sorry. Right here. We put our dot here because there's 3 from that one and 3 from that one. So here's our dot. Now, in this group, let's circle these 5 dots and bring us a little dot over here. So here's this another set that has 5 dots. So we'll circle those and put us a dot here. Now we'll just carry it down. So in this column, there aren't any dots that aren't in a big circle. So we'll put a 0. Over here, there's 2 dots that are left out. So we'll put 2 down here. This area, we have 1 dot left out. So we'll put it here. And there's this one. So the answer to this problem is 1,120. We're going to work a couple more, so don't worry, guys. This one is to the base of 6. It's just like we just did with the base of 5, but instead of doing 5 to the power of 1 or 5 to the power of 2, it's going to be with 6 to the powers, okay? So 628 to base 6 plus 73 to base 6. So we'll do the same thing we did above. 6 to the 0 power gives us 1. 6 to the 1 power gives us 6. 6 to the 2 gives us 36. 6 to 3 gives us 216. Now our first number is 628. So just like I said before, there's 3 digits, so we're going to put it in these 3 places. So we'll put 6 dots, then 2 dots, and then here's our 8 dots. And we'll do that the same thing with 73. Now 73, there's only 2 digits, so they're going to go in the last 2 spots. So we'll put 7 dots in here, and they'll put 3 dots over here. Now instead of circling groups of 5 dots like we did before, we're going to circle groups of 6 dots. So here's one group of 6 dots. We'll circle it, and we'll bring our dot over here. And that leaves us with 5 dots, which we put down here. We'll come over here, and we got to circle the group of 6. So here's 6 dots right here. And we're going to put us a dot over here. And then we circle this group of 6 dots, and we'll put our dot over here. And now we're going to bring down our dots. So we already did this one. There's 5 dots left, so we bring it down to 5. Here we have 1, 2, 3, and 4 dots. So bring down a 4. This one, there's only 1 dot left. And over here, we got 1. So the answer is 1,145. I hope you guys are getting these addition ones because I'm fixing to mix it up, and we are fixing to do a subtraction. Now this is just similar to like regular subtraction. You know, it looks a little tricky because there's dots, and oh my goodness, what do we do? I'm fixing to show you guys. So we do the same thing we did before. 5 to the 0 power, 5 to the 1, 5 to the 2, and 5 to the 3. And we fill it in. So we have 414, which is 3 digits. So we got 3 spots to fill. So we put 4 dots, then we have 1 dot, and we have 4 dots. Minus 43. So we have 4 dots, and then we have 3 dots. Now, 4 minus 3, just like we would do in a regular subtraction problem, we'll cross out our dots. There's 1, 2, 3, and that leaves us with 1 dot, so we go ahead and bring that down. Now this next column, remember we just had this 1 little dot, and we have 4 down here. So we can't work that. We'll come over here and we'll borrow the sets of 5 right here. So we'll cross one of these dots out, and we'll come over here and draw 5 dots. 1, 2, 3, 4, and 5. Now we have enough because we have 6 dots. We can subtract that from 4. So, or subtract 4 from 6, sorry. Let's mark out our dots. 1, 2, 3, 4. And that leaves us 2 dots, so we'll bring down the 2. Now over here, there's 3, and there's no dots in this column right here for this number. So we'll just bring down the 3. So the answer to that's 321. since I messed up a little bit, let's go ahead and work the last subtraction problem. That way I know for sure you guys are getting the hang of this. Now, 503 to the base of 5 minus 24 to the base of 5. So we'll work the same thing. So we got 5 to the 0 power, of course, is 1, 5, and then 25 is our columns. So we put 5 dots in this column. There's 0 for this one. And then we have 3 over here for this column. And then we have 24. So we have 2 dots and then 4 dots. Now 3, 4. You can't take 4 from 3. So we're going to have to come over here and borrow from this dot. And we'll bring 5 dots back over here. So now we have 8. So 8 minus 4. So we'll cross them out. 1, 2, 3, 4. So that leaves us with 4 dots. So we bring down the 4. Now over here we cross that one out so he's no longer here. That leaves us with, oh, we got to, sorry, come over here and we're going to have to borrow from this guy. So let's cross him out and bring us 5 dots over here. So we got 1, 2, 3, 4, 5. Yeah, and I missed it. Anyways, so we cross off 2. 1, 2. He's not here no more. So we got 2 dots. Bring down the 2. That leaves us with 4 dots over here. So our answer is 424. Now I hope this has helped you guys with solving your number systems and sets and multiplication lattices, and even estimating and getting the correct answers. Well, I hope I've helped you guys in solving your problems, and thank you for watching my video.